This presentation is about sets. We have some practice questions, and then I'll be explaining what is complement of a set is. Also, we're going to learn how to shade the Venn diagrams. Look at this question. Read each Venn diagram and answer the questions that follow. A leasing company conducted a survey to find how many residents in an apartment complex use the swimming pool and gym facilities. So this is the diagram. S is the swimming pool. G stands for gym. So the first question is, how many residents use both facilities? You can see both swimming pool and the gym facility. The answer is over here, which is 90. How many of them use the gym? So when they say the gym, this is the gym. So this circle represents the gym. So now you cannot debate, okay, this 19 is also used in the swimming pool. No, don't debate. If you start debating about the question, you can't answer the sets questions. Just read the question and answer what they have asked. The gym. This is the gym. That's all. So it's 19 plus 87. Together it's 106. The next question is, a chocolate manufacturer conducted a survey among visitors to find which flavor of chocolate was more popular, milk chocolates or dark chocolates. So you can see under the milk chocolate, that's the circle. This is the dark chocolate. So what's the first question? How many visitors preferred dark chocolate? No debates. Don't think of anything else. Just consider this word dark chocolate. This is dark chocolate. So that is 31 plus 53, which is 84. Find the total number of visitors who took part in the survey. So total number of visitors, that is 76, 31 and 53. So all these are the visitors who took part of the survey. So you have to get the summation 76 plus 31 plus 53, which adds up to 160 visitors are there who took part in this survey. Look at this question. The Venn diagram below represents the students in grade 5 who have enrolled for the school soccer and baseball summer camps. So this is the information. S stands for soccer and B stands for baseball. First question is, what is the total strength of grade 5? And the next question is, how many students have not enrolled for the summer camps? So I'll give you a few seconds. Check and see whether you could answer this question. Okay, so the part A, what is the total strength of grade 5? So the total strength of grade 5 is this universal set. So this is the total strength. That is 12 plus 4 plus 16 and this 5. So this total strength is 37. How many students have not enrolled for the summer camp? You can see that over here, these students who are within these circles, they have enrolled for baseball or for soccer. But these 5 outside here, they are there in the grade 5, but they have not enrolled for any of these camps. So the answer here is 5. These 5 students have not enrolled for the summer camp. The Venn diagram below represents customer preferences in a cafe. Cold coffee and lemon cake. So look at this. The first question. How many customers placed orders for cold coffee at the cafe? So you can see this particular circle shows the number of customers who ordered a cold coffee. So it's 3 over here, 4, 5, 6, 7, 8, 9, 10 and 11. So we have 11 customers who have ordered a cold coffee. Next question, how many of them indulged in both lemon loaf cakes and cold coffees? So you can see that means they refer for both, cake and coffee both. That is these three. Over here they have ordered a coffee and a cake. And the last part, it's C. Find the number of customers who placed orders for lemon loaf cakes alone. That means they want only cake. Only cake is this part. It excludes the coffee circle. So we have 1, 2, 3, 4, 5. So this 5 over here, they need only a piece of cake. Okay, so this is only 1, 2, 3, 4, 5. This is these 5 customers that they want only a loaf of cake. Complement of a set. The following is a Venn diagram that shows set A within the universal set U. A dash, the complement of A is shaded. Look at the figure. This is the universal set. And I have drawn the set A inside the universal set. And you can see what is shaded outside over here is A dash. That is A complement. So what do you mean by this A complement is excluding A, without A. Look at this example. So the universal set is 2, 3, 5, 7 and 8. So what are the elements of A? That is 2, 7 and 8. So what should be the elements of A dash? That means excluding A. Look at the universal set and cut off the elements of A. 2, 7 and 8 is gone. So we have 3 and 5 which is not in A. So you can call this 3 and 5 as A complement. And this is how you show it. This is the set A and I have input the values 2, 7 and 8, the elements of A within that set. And the other elements which are not there in the set A, 3 and 5, I write it inside the universal set. So 3 and 5 means the of A dash, which is complement of A. So this is how you represent it. This is A dash, okay, not A. This is another example. So the elements of the universal set A, B, C, D, E, F, G, H. And the elements of set A, that is A and E. Elements of set B, E, G, H. So when I draw this into the Venn diagram, you can see E is the common element. I have written it in the common region. And simple A to the left of the diagram and simple H and G to the right of the diagram. And A union B, so as we learnt before, union means all the elements of A or B, that is A, E, G, H. Look at this now. A union B dash, that means the complement of A union B. I said you the complement means not. So what are the elements which are not there in A union B? So you compare it with the universal set. You can see C, B, D and F are not there in A or B. That is A union B. Nextly, A intersection B. So intersection refers to both or common. So you can see E is common for both A and B. And if I say A intersection B complement, that means which is not there in A intersection B. So you can see except E, all the other elements are not there in A intersection B. So A intersection B complement is A, B, C, D. E is not there because E is there for A intersection B. So we exclude that. F, G and H. You try this example and see. So the universal set represents few months. And they ask from you A union B complement, which is A union B dash. A union B means all in A or B. So that means you have to exclude the months that is in A or B. So January, March, June, May, October, August are there in A or B, except that excluding those months, July and September are the 2 months which excludes from A or B. Nextly, A intersection B, that is common for A and B, June and May. And they ask from you finally what is A. When they say A, it just you refer to this A circle. Don't worry about this May and June, whether it's also belong to B. No, don't think of the things which is not said in the sum. You check with the things that the question asks. Question says A. A means this full circle. Just this circle. So it's January, March, June, May. All these things belongs to A. So the answer is January, March, May, June. All the 4 months belongs to A. We are going to start how to shade the regions in a given Venn diagram. In this Venn diagram, you can see A is shaded. The set A is shaded. So what is the region which this set has shaded? It is simply A. In this one, you can see the set B is shaded. So what is the region which this particular diagram has shaded? That is B. Look at this. It has shade all A or B. It has shade all A or B. So we can call this as A union B. They have shade only the common region. So common means the intersection of what? A and B. So we have A intersection B. Okay, this one. Can you see they have shaded only A? Only A. So in that case, you can see they have excluded B. So we are going to start this with B naught, which is B complement, intersect with, common with what? A. So B naught, that is excluding B, common to whom? Common with A. Look at this. That is also the same. Excluding A, common with B. So you can see the region which they have shaded is only B. Only B means excluding A, that is A complement, except A, nothing in A is shaded. Common with whom? Common with B. Look at this region which has shaded. They have shaded excluding A, everything else. That means we can show it as A dash. The next one, we discussed about this in the previous slide also, that is excluding B, A complement, common with A, intersect with A. But if you look at this diagram, it is also excluding B, but you can see that the full A circle is shaded as well as the outside region is also shaded. So that means they have shaded full A. Here the A circle is shaded. that is this A, and B dash. B dash means excluding B. Without B, everything else is also shaded. So in this case, it is not the common region that they have present. They have present all in A and all in not B. So we call this as A union B dash. This is excluding A, without A, common with B. Common with B. They have not shaded the B full circle here. Only the common part of A dash with B is shaded. So this is A dash intersect B. But if you take this diagram, they have shaded the full B circle. That is this B over here. And they have shaded A dash. A dash means everything else without A. So all what they have shaded is given in the diagram. That means A dash union B. Everything in A dash, excluding A, everything, along with this B, also with B. So it is not the common region, it is all. That means the union. So you can clearly see the difference between the intersection of A intersect B dash with A union B dash. Intersection means you have shaded only the common region for A and B dash. Union means you have colored, you have shaded all in A and all excluding B. That means complement. So we are going to learn about disjoint sets. What are these disjoint sets? The two sets are not joined. So there is no common region when they are not joined. So if they want you to shade the union of a disjoint set, you can see that the set A and B has no common region. It has drawn separately within the universal set. So you have to shade both the circles A and B, both the sets, this and this separately to show that you have shaded all, which is union of the disjoint set A or B. Intersection of the disjoint set means disjoint says there is no intersection, there is no common region. So you can't shade anything to show the intersection of a disjoint set. Disjoint means the sets are not joined. There is overlapped area. Finally, I will explain you about each region of this Venn diagram. So this part is A only. This is what? B only. What about this? C only. But if they say A, it includes everything over here in this A circle. It includes all these four parts, this gray, this brown, yellow, green. All these four parts belongs to A. But if they refer to A only, that is this gray part. Look at this. What is this part? This is AB only. A and B only. That region is common for A and B only. There's nothing to do with C. And this is, okay, so it's B and C only. And this part, A and C only. Also that small part right at the middle, that is common for all three, A and B and C, that is all three is there. So dear students, I prefer if you could write this entire note in your writing book. So when you follow it up, you will understand it more. Rather than just watching this presentation, if you could write it of your own, and if you could shade the relevant regions, if you could answer the questions, you will understand this more. And my next slide, the next presentation, I will do some past paper questions of Cambridge O-levels that is relevant for sets.